Welcome to Tenor Tech, where I solve the problems you didn't even know you had.
You start by loading your EIS files into the fitting environment and immediately inspect frequency coverage. This step matters because gaps ruin fits. Once loaded, trim the lowest and highest decades if they show noise, and make sure phase is unwrapped correctly. You then scale magnitudes so units match your model, because mismatched units bias parameters. Finally, save a working copy. This lets you run fits iteratively without corrupting raw data. You now pick an equivalent circuit that reflects mechanisms you suspect, and you explain why each element is present: resistors for ohmic drops, CPE for non-ideal capacitance, Warburg for diffusion. Once chosen, set initial guesses and hard bounds based on order of magnitude estimates, because the optimizer needs a realistic starting point. Then choose a weighting scheme, 1 over magnitude or phase weighting, and select chi-squared or least squares as your objective. This controls how high and low frequency points influence the result. You execute the fit and watch residuals in real time. A structured residual pattern signals model mismatch, while large parameter correlations mean non-identifiability. Once done, validate with bootstrapping or Monte Carlo to get confidence intervals, and compare fitted and raw Bode and Nyquist plots to confirm visual agreement. If things go wrong, simplify the circuit or constrain parameters, because fewer degrees of freedom often stabilizes fits. Also recheck preprocessing for outliers or improperly unwrapped phase as the first troubleshooting move.
Thanks for watching. Subscribe to keep your life in tune.